Okay, so 8.1 simplifying expressions. There are a few steps. The first step we always want to do is factor completely. Factor completely, and I mean the top, the numerator, and the bottom, we want it factored completely. So if we look at number 2, we can see that the top is factored completely. So in other words, with y minus 3, they don't have anything in common that we could take out to factor it even more. Same thing with y plus 4. So the top is already done. It's already factored as much as we can. The bottom, I'm going to leave this y alone, but I have this quadratic right here that I can factor. And I factor by finding my factors of -6 that can add together to give me my middle term, which is -1. That's going to be -3 and 2. And because my a is 1, I can rewrite this as y minus 3 and y plus 2. Alright, once you've completed step 1, you've factored it all completely, which we have. Step 2, we are going to check where the bottom is 0. So we're going to set bottom equal to 0. And the reason we do this is because if we were to plug any number in for y and it gave us a 0 in the denominator, it would be undefined because we can't divide anything by 0. So we're going to set each one equal to 0 to make sure or find out where our restrictions are. So the first thing we'll set equal to 0 is y, so y equals 0. So in other words, we could not plug in 0 for y because we'd have a 0 on the bottom because all these are being multiplied together. Because that would give us 0 in the denominator, which we can't have. Then if we set y minus 3 equal to 0 and solve, we would add 3 to both sides and get y equals 3. On this one we get y equals -2. So these are our restrictions. This is what y could not be because it would give us a 0 in the denominator. Step 3, we're just going to simplify. So if I look at this equation that's factored, I see that a y minus 3 and a y minus 3 is on top and bottom. And when I divide these, they'll cancel out to just 1. So I can cross these out. And now this 4y and y, I know that 4y divided by y is just going to give me 4 because the y's will cross out. And now on top with the 4, I will have y plus 4. And on bottom, I will have y plus 2 left over. And I can't cross anything else out, so this is my final answer. The only thing I need is, comma, x cannot be, and this is where this comes in. Or excuse me, y cannot be 0, -2, or 3. Alright, next one is number 3. And again, the first step, we have to factor it completely. So in the top, the 2x and the x minus 5 is already factored completely. But this quadratic we can factor by finding factors of -8 that can add together to give us 2. And that's going to be a +4 and a -2. On bottom here, all of this is already factored. So we can bring that down. So now it is factored completely. And now we can set the bottom equal to 0. So if we set it equal to 0 and solve here, we'll get x equals 1, x equals -5, x equals 2. And last thing, simplify. So I can see here that the x plus 5s will cancel out, the x minus 2s. So up top, all I have left is 2x and x plus 4. X plus 4 over x minus 1. And then the last thing I need, comma, x cannot be 1, -5, or 2. That's it. Alright, so the next thing we're going to be doing is multiplying expressions. We still have the same first step. We're going to factor it completely. And then this time I'm not going to have you set the bottom equal to 0. I just want you to do that when the directions say simplify. So on number 5, first thing we're going to do is factor. when we multiply expressions, factor completely. So let's go ahead and take care of that. So for this quadratic, what two numbers can multiply to get negative 16, add together to get negative 6? That's going to be negative 8 and positive 2. On bottom, what can multiply together to get 64, add together to get negative 16? That's going to be negative 8 and negative 8. Up here, this is already factored as much as it can be, the x minus 8. So we'll move on to this. What can multiply to get 6, add together to get 5? That's going to be 3 and 2. So, let me take you back to like, I don't know, 5th, 6th grade when we had fractions. So I'm going to write this on here actually. So when I have the fraction and they had big numbers like 12 over 30 times 5 over 48. And say if we did not have a calculator, so when we multiply them, we'd have to do 12 times 5, 30 times 48. And 30 times 48 would be kind of hard without a calculator. So what did they teach you in grammar school? We can cross simplify. So what do 12 and 48 have in common? 12. So I can mark this out. 12 goes into 12 one time. 12 goes into 48 4 times. And then same here, what goes into 5 and 30? 5. So I can make this 1 and this 6. So now when I multiply straight across, I have 1 times 1, which is 1, 6 times 4, which is 24. And that's a lot easier. We can do the same thing with rational expressions. We can cross simplify before we multiply them together to create less mess. So when we're looking crossways right here, I see that the x plus 2's can cancel out. And crossways here, I can see that the x minus 8 and one of the x minus 8's will cancel out. And now I could either multiply straight across, or I can see, look at this top and bottom. I can also simplify here. So x minus 8 and x minus 8 will cancel out here too. And then, so what would be left on top? That would be 1 is left on top. And on bottom, all I have left is x plus 3. And that's it. So over here, we don't have to factor first because it's all one term. So we can skip straight into cross simplifying. So let's look at our coefficients first. So 3 and 18 both have 3 in common. So I can mark this out and put 1. Mark this out and put 6. Okay, and now I look at the A's. This one has A, this one has an A. So A divided by A would just be 1, so those would cancel out. But if I look at the B's, this one doesn't have any B's up here, but this does down here. So I can't really simplify, so I'll just have to bring down that B cubed. Alright, the C squared, I have a C cubed up here, C squared down here. So when I subtract the exponents, because we're dividing, 3 minus 2 will give me 1c, and it'll go where the bigger exponent is, which is up top. So right here, 3 minus this 1 would give me f squared, and the 3 is the bigger exponent, so that's where the f squared will end up. Now let's cross simplify this way. So 8 and 12 both have 4, so this will become a 2, this will become a 3. Now I have a and a squared. Well, the difference between a squared and a would be just a, but it goes where the bigger exponent is, which is on bottom. Right here I have b squared minus b. That gives me just b, and it'll go on top where the bigger exponent was. The c's will cancel out, and I'm left with f to the 4th right here. And now I can simplify up and down this way. So I can cross out these f's. The difference between f squared and f to the 4th would be f squared, and it will go where the bigger exponent is, which is right here. So this becomes f squared. This one cancels out. Right here, 3 and 6 both have 3 in common, so this could become a 1. This could become a 2. And then the difference between b cubed and b is just b squared, and it'll go where the bigger exponent is. So we have a squared right here, nothing right here. Now when we multiply straight across, we just have one c on top, that's just c, over 2 times 2 is 4ab squared f squared. Alright, next one we're going to have to factor. So I'll start with 8x and 20. What do they have in common? That would be 4. So if I take a 4 out of 8x, I'll get 2x. 4 out of negative 20, negative 5. On bottom right here, I have to see what can multiply to give me negative 35, add together to give me 2. That's going to be x plus 7 and x minus 5 times. This one would give me x minus 5 and x minus 2. On bottom here, what do these have in common? A 4. So we bring out a 4, and this makes x squared minus 4. And we can actually keep factoring x squared minus 4 using difference of squares. And let me go back to difference of squares to review. So if you have a difference of two perfect squares, for example, 4x squared minus 9. So it has to be difference, and both of these have to be perfect squares. So the square root of x squared, or actually let's go back. Let's do x squared. Let's do our example. Minus 4. So say if we didn't know this was difference of squares. If we were going to solve this, so let's set it equal to 0, we would add 4 to both sides, get x squared equals 4. And the square root of both sides would be x equals, and then the square root of 4 would be plus or minus 2. So how would we write this as two binomials? It would be x plus 2 from here and x minus 2 from here. This is the same as x squared minus 4. So the x really comes from the square root of x squared. The 2 comes from the square root of 4, plus 2 and minus 2. So one more example with difference of squares. If we had 4x squared minus 9, square root of 4x squared is 2x, square root of 9 is plus or minus 3. So to write it as two binomials, it would be 2x minus 3 and 2x plus 3. Alright, so back to work. Alright, so we can simplify this x squared minus 4 to x minus 2 and x plus 2. Now we can cross simplify. So looking across, the only things we could cancel out would be this 4. Looking across here, we can cancel out the x minus 5. And now up and down, can we simplify? No. Up and down here, yes, we can cancel out the x minus 2. So on top, we would have 2x minus 5. On bottom, we would have x plus 7 and x plus 2. And that's it. Alright, next one is talking about dividing expressions. And if we go back to thinking about fractions in general, say if I gave you 1/2 divided by 3/4. To divide fractions, we have to keep, flip this, and change to multiplication. And then you can just multiply straight across. It'd be 4/6 or 2/3. Same thing with rational expressions. We have to keep, flip, change. So I'll go ahead and do number 8. And since they're the same as this up here, you just have to flip the second one. I'm going to let y'all do the rest on your own. So for this one, for dividing, let's look at this top first. Let's factor it. This is difference of squares. So the square root of x squared is x. Square root of 16 is minus 4 or plus 4. On bottom right here, what do these have in common? 12. So it'd be 12 on the outside x plus 3 on the inside. And now this needs to become multiplication. These are going to flip, but we can go ahead and factor it. So the bottom factored, we would have to use 6 and 3, and the 6 would have to be negative. And now to factor this one, but I'm going to put it on bottom, we'd have x minus 8 and x minus 4. So now we can cross simplify, so the x minus 4s will cancel out, x plus 3 will cancel out. Doesn't look like anything else. So on top we'll have x plus 4, x minus 6, on bottom 12, x minus 8. And that's it. So like I said, the other two are the same, just with division you just got to make sure that you remember to flip the second equation. But other than that, they are the same. Let me know if you have questions.